We explain about my code and also make about run demo. So let's go straight to it. So you can see in here the first thing I'm just great about the matrix multiplication, and this one is just like about simple one, which is like about we create about the column and row of the matrix, and everything is the same for both the OpenCLs and also the APIs. And in here I'm just doing like create a matrix sign without doing anything, which is the default thing where like is we calculate about in the CPUs, and it's also running sequential. It's not like doing anything in parallels or distributed programming. And I could initialize a matrix A and B with about a random value, and then calculate about the time execution, and then I release the memory in order to like make all the thing can running instead of just storing in the buffer. So yeah, and how about the OpenCL? So in the OpenCL, because I don't have any GPU, so it will like fall back to the CPU. So about the performance might be like worse than the if I'm using in the GPU. And in here, create about the first thing I need to create about the kernel function, and the OpenCL you already know like about we need to run this thing like it can be changed, like we can use in the GPU or we can use on the CPU. It's depend on whether you have that thing or not. Like if you use in a GPU, it's will running a lot of parallel programming, everything will be like running at the same time without which make it faster to execute the time. And the matrix multiplication is the same, and I create about the kernel function with e split array like about like array function, like it will calculate about room the column and the rows like at the same time. It's not like calculating like sequential. And in the main function I'm still great about this about the matrix. I create about three matrix A, B, and C, and I initialize it with about random values. And then this is about my device, which I'm using about Apple silicon chips. And this is how I create about the OpenCL. And if it already if this thing like get the GPU, it exactly will just like running at the GPU execution times. Otherwise it will fall back to the CPU, which is we just like calculating it. And yeah, and I also like freezing about the memory. We still doing the same, except like we adding about more function in the GPU. If you taking this code and then running to all the device which all the computer which have the GPUs, it will also work. It will run it in this one, which it calculate have the buffer in here and everything. And how about this MPI? MPI which is like is much be faster than about the sequential, because like we can optimize about the CPU we have in the computer in order to make it running. Like it will be like distributed programming. It will like distribute to like all the things working, and it will like split like every calculation into the subtasks in order to run this one. So the matrix multiplication is same, except like in the main function I need to like initialize about the MBI, which is telling okay I'm using about the MBIs, and also create a break of the process, and then the number of process I want to using it. And the next thing I create about the matrix sign, and A, B, and C, three matrix sign here. And I'm exactly which is like in order to make it running distributed in a different CPU, which is like process this thing, and then I calculate the process. And after that I'm just like like I need to like calculating the time, and also like gather everything together again, like about gather everything, because like I'm already distributed, I'm already processed this thing, and now it is time for me to merge everything together and then give about the final output. Then free memory again, and then the MPI. So let me just running again to make you clear to see. And the first thing I'm need to running you about the sequential matrix first. Like it will take a while. It will take like a little bit time, because like I can create about with the matrix size 1500. So you can see in here we got like 9.25 seconds. And the next thing I will be running in about the OpenCL. So you can see like no GPU certified file is exactly just like falling back to the CPU. And yeah, you can see in here the timing a little bit like faster than the sequential, but like because it's still using in the CPU, so yeah, it's not very fast. How about we are running in the APIs? Okay. You will see like it must be faster than about both sequential and the OpenCL with running with the CPU, because like Open API using about the like open using about distributed programming. So but what if it using in the OpenCL running on the GPU, and this one running MPI, when you compare it, it's exactly what just like we will see it's much clearer in order to compare between them. But in here I don't have about the GPU to running it. So yeah, so that is all the thing I have been explained here. Thank you.